But like the restricting part where you have to make the inverse a function.
Okay.
Yeah.
Yeah. That makes a lot of sense. So we'll have a look at that. So it means we need to have a look at the inverse, sketching it and restricting it such that it will be a function. So maybe a quick question is, you do remember what needs to happen to an inverse or to any graph to be considered as a function, isn't it? So I'll just say here, this is just a quick revision. So if you remember, f of x is considered a function if it passes the vertical line test. So f of x is considered a function if it passes, it's a bit cold today, my handwriting is something else, the vertical line test. So that is what you need to do. You need to restrict such that we pass the vertical line test. And with the vertical line test, all what we are saying is that if we draw a vertical line, it should touch the graph once. That is what we are saying. If we draw a vertical line, it should touch the graph once. It should touch the graph once. That is what we are saying. So as an example, before we get started, if I have sketch like this with this our Cartesian plane, then I have a parabola that looks like this. This parabola of ours will not be a function if it is like this, because if we draw our vertical line, it will touch it at 2 points. So it will touch it there and there. And we said for it to be a function, it must be, the vertical line must be touching it at 1 point. So this f of x here, which would be, as an example, yeah, let me just leave it as f of x. This f of x here is not a function. Okay. However, if we can restrict it, we can make it such that it becomes a function. What do I mean? We quickly have a sketch below, another one. And we restrict such that we only have the upper part like this. Okay, why does it not want? So we restrict, let's say, our parabola, which would have been like this, such that we only have the upper part, meaning the bottom part here is erased. So it's erased the area such that that bottom part is erased. And then we are only left with the top part. This here becomes a function, because if you do a vertical line, you will see that our vertical line only touches our graph at 1 point. So what we have here, which we can call g of x, this one here is a function because it passes the vertical line test. When we draw a vertical line, it only crosses this graph only once. So let me quickly fix something here. So that g of x is a function. So now the question which we need to answer is, how do we restrict this such that this happens here? And also, maybe the last sketch, if we had a graph that looks something like this, we know that this is not a function, okay? But we can restrict it such that it passes the vertical line test. How? Either we need to remove the top part or we remove the bottom part. So let's try that again. So if we have one that is something like this, we can either focus on removing the bottom part or the top part. So maybe we can remove this top part here. So instead of it becoming that parabola, it becomes something like this. And when we do the vertical line test, you will see that it will now only cross this function once. So it will now cross this function once, which means it will now be a function. So if we take this and we call it h of x, this one here will be a function because it passes the vertical line test. And if you think carefully, the real difference is in part trying to restrict what kind of a function we have here. So if you think about it carefully, let's go to the next page and we deal with this restriction, and then we'll come back to what is happening later. So I need you to consider a function. So let's consider f of x. And we want f of x to be ax squared. And for this case, I want us to work with an a value that is positive. So if we sketch the original function, this f of x here, what you will see is it will be a graph that looks something like this. Do you agree? A is positive. Okay, awesome. I see a thumbs up. So now let's go and worry about the inverse. So how can we get the inverse for this graph? So remember, whenever we are looking for the inverse, we must do two things. We must first swap x and y, then afterwards solve for y. Okay, that is what we do when we do inverses. So when we look at our problem, you will see that what we are given is y equals ax squared. So we can start our inverse process. Swap x and y. So wherever there was y, we put in x, a. Wherever there was x, we put in y. Then now what we need to do is to solve for y. So if you look carefully, you'll take the x and divide it by a. It's an example in this case. And this will be y squared. Then you take the square root. So your y will be plus or minus the square root of x divided by a. Okay, that is what our y value will be. And then what we are going to do is we are going to go and plot this. So what you should remember is that a is positive, okay? And we know that we can't work with negative square roots. So it means that even our value of x must be positive. So the only thing that will just change, it is just the y values, okay? So now we can go ahead and say our inverse f minus of x will simply be plus or minus the square root of x divided by a. So let's take the same graph now and put in our inverse. Let's paste it here. And then if you observe carefully, if we put in our inverse, which I'll make to be purple, it will be something like this. Our inverse will be, maybe let's move this f of x to the side. We move it down. Sorry. Sort that out. So if we put in our inverse, what you will see is it will end up being something like this. That is how our inverse is going to be for this parabola. And there's two things now which you need to keep in mind, the bottom part and the top part. So remember, for our inverse, we found our inverse to have an equation of plus or minus the square root of x over a. So if I can color code this and make the bottom part to be red, let's maybe highlight that and make it to be that. So if you look at the bottom part, if we make it to be red, you should see that the bottom part, when you look at our equation, it is actually f minus. It is the part that takes the negative. x divided by a. Then if we look at the top part, let's just make it to be blue. That is okay. Well, purple. You look at the top part, which is purple. It is the part that takes as part of the inverse equation. It is the one that is the plus square root of x divided by a. Do you understand? So meaning, if now we have our inverse, in order for us to tell them which of the two graphs we are working with, because if you look carefully, this is definitely not a function, this inverse here. If we draw a vertical line like this, it fails the vertical line test because we are crossing there and there. So that fails the vertical line test. So now how do we make it to be a function? Is the question which we want to answer, which is how do we make that f of minus 1 or the inverse a function? So how do we make the inverse f minus 1 of x a function? So it must pass the vertical line test. And the answer to this is we are going to restrict the domain, not the domain, sorry, the range. That is the answer. So the answer is very simple. So answer, what we are going to do is restrict the range. So we need to restrict the range of the inverse. But guess what this does? If you restrict the range of the inverse, this is the same as restricting the domain of the original function. Do you understand that? So let me quickly make a note of it. So if you observe carefully, did you get my question?
Yes.
So my question is, do you understand that when we restrict the range of the inverse, we are restricting the domain of the main function because they are swapped?
Yes.
Yeah. So maybe let's focus on that, because what you should understand is that the range of the inverse is f minus of x is the same as the domain of the original function f of x. So if you observe carefully, how we can restrict the range of f of x will depend, of the inverse will depend on what we want. So if we want the bottom function, what we are going to say is that y must be less than 0. This would ask if we're wanting the bottom function. Do you understand?
Mm.
So we are saying we are looking at negative y values, and that would mean we are only working with the bottom function. However, if we want to restrict such that we have the top function, we would use the y value. We would say let y be bigger or equal to 0. And this would only leave the top function or the top part. Okay, that would be us forcing this thing to be a function. So if I can go to the next page, if you look carefully, we can restrict it in two ways, which we have spoken about. Let me move this. I'll deal with these now. So we said we have two options. It's either we restrict such that we remove this here, and now our inverse would be a function, or we remove the top part. And when you remove the top part, the bottom part would all be a function. Okay, these are the two ways that we can restrict such that we have a function. So with this one, if you remember, we said we will say that the range, we copy this. So for the top one, this is less than 0. So this would be for the bottom one. Okay, that would be how we restrict the bottom one to make it to be a function. Then the top one, let me make some space. So for the top one, we would put in this restriction on the range of the inverse. And remember, the range of the inverse, it is the same as you restricting the domain. So this would lead us to having the top part. Okay, so this is done. Do you understand what I did?
Yes, sir.
Okay, good. So with that said, let's go and deal with some questions here. So let me add just a few pages and we see if we can make sense of these questions. So let's start with this one and see what is happening. So we're looking at question 4, which reads, in the diagram below, f of x is ax squared. It is drawn in the interval x is less than 0. Okay. And the graph, the inverse is also drawn. And they say the point P, which is -6 and 12, is a point on F, and R is on the inverse. So they ask us, is F minus 1 or the inverse a function? So what do you think about that question there, 4.1?
Yes, sir, it's a function
So why is it a function?
because it passes the vertical line test.
Yep, that is correct. So if you look at that inverse, it is something like this. Not sure why this thing thinks I want you to draw a straight line. Let me quickly sort this out. So if you look at our inverse, it is something like this. That is our f minus 1. So if we do the vertical line test, as you correctly point out, we'll only cross at one point. So it passes the vertical line test. So we can clearly and confidently say that the inverse, which is f minus 1 of x, is a function. Why? It is a function because it passes the vertical line test. Vertical line test. Okay, done with that. Let's have a look at 4.2. 4.2 says R is the reflection of P in the line x equals y. So write down the coordinates of R. So let's go ahead. They are saying here R is a reflection of P, reflection of P, and this is about the line x equals 1, x equals y. And if you remember, what I said is that when they are saying x equals y, all what they are saying here is that inverse. This is just an inverse. What do we do with inverses? We swap x and y. Okay, so if P is -6 and -12, and R is the inverse, then R will be -12 and 6 and -6. Do you understand?
Yes, sir.
Okay, then let's go to 4.3. So 4.3 says calculate the value of A. Okay, so we now have the graph f of x. So we know that f of x is given by ax squared. Okay, so we'll calculate A, but look at R. So R is a point on F. So R is a point on f of x. So let's go ahead then and use R, because R, which has those coordinates, let me put them -12 and -6, is a point on f of x. So we can go ahead, wherever we see y, we put in -6. Wherever we see a, we leave it as is. Wherever we see 12, so wherever we see x, we put in 12. So this becomes -6 equals 12 squared is 144 times a. So we're looking for a. So this means we must divide by 144, divide by 144. So what is the answer that we get for a?
-1/24.
So we get -1 divided by 24. And this does make sense. And it makes us happy because if you look at the part of the inverse, or if you look at the original graph there, not the inverse, if you look at the original graph, you will see that one part of it is actually facing down. So the original graph is concave down. So it is something like, is going like this. And this makes us to see that we have concave down. So when we get a negative, we are not surprised because that is what the f of x graph is, ax squared. So we do expect a to be less than 0 or negative. Right. Then 4.4, let me create some space and we try and squeeze it here. So where we are required to find the equation of the inverse. So we'll just swap x and y. So let's go ahead. So we're looking at 4.4. So we know that the equation f of x is -1/24 x squared. So I'll just write it as a as y equals -1/24 x squared. So we are required to find the inverse. So for the inverse, you know that what we are going to do is to swap x and y. So let me do so already. So this means we are going to have x equals -1 divided by 24 times y squared. Then when we divide by -1/24 on both sides, we'll end up having -24 x equals y squared. Do you see that?
Oh, yes, sir.
Okay. And then now what we need to do is to take the square root of both sides. So therefore, we take the square root. We'll have y equals plus or minus, if you observe carefully, the square root of -24x. Okay. And remember that our x value is always negative. So our x value, as they specified here, it is negative. So now we need to choose which of the graphs do we choose. So remember, when you were finding the inverse, the other graph could have been up here, because remember, your parabola is always something like this. So now with this in mind, in looking at the y values of the inverse, which of the two solutions should we take? Remember, there's a +1 and a -1. Look at our square root, plus minus. So which of the two is the inverse? Therefore, for x minus, so therefore, our inverse will be, so do you see that our inverse will always have negative y values?
Yes, sir.
So it means our solution is a positive y value and a negative one. So it means I need to look at my inverse and say, okay, the one we have looks like the one that is negative. So our answer is going to be negative square root of -24x. Do you understand?
Yes, sir.
Okay, awesome. So when you were trying this question, where did you get confused? If you did.
Yes, I did. So I didn't understand the restricting part from the very first place. So question 4.4, was a little bit confusing.
Okay. Do you now understand the restriction part?
Yes.
Yeah. So you look at these things. So we have two solutions. Once we have a plus or minus on the square root, it means we have two solutions. Now we need to look at our graph. Is it the negative component of the graph? Because this graph actually continues like this. But if we want to make it to be a function, as I showed you here, we either need to take the top part of it or the bottom part, and the other part disappears and you never see it as you did here. And that now requires you to force the y value. For the top part, we choose a plus. For the bottom part, we choose the minus solution. Very important that you understand this, and I'm happy if you are seeing the light. Okay? With that said, let's go to the next one. Let me see, there was another one. Okay? Let's have a look at this one. So let's quickly have a read. So 5.5, study the diagram which shows the sketches of v of x equaling plus or minus square root of x, and our w of x equals log of x. State whether v of x is a function or not. So what do you think of this one here?
It's not a function, so,
And why
because
is it not a function?
it fills a
Yeah,
vertical line test.
you are correct. So if we go ahead and put in our vertical line here, you will see that, let's try that again. You will see that it will fail. The vertical line will cross the graph twice, and we said it must not, it must only touch the graph once. So our conclusion here is that this v of x is not a function. So we'll just say v of x is not a function. And the teacher will say why, and we know why. It fails the vertical line test. Okay, so this was a giveaway. Let's go to the next question. 5.1.2. So 5.1.2, they say, write the conditions that will make this graph to be a function. Now we need to think carefully, okay? We need to think of the x values and also think of the y values in mind. So let's go ahead. Let me maybe put up a sketch of this here. And yeah, let's put in that graph of ours like that. So we said when we were talking about making this to be a function, we said there's really two ways we can go about this. So it's either we take the top part or we take the bottom part. Now, if you think about it carefully, and I need you to think of the original function. So the original function must have been like this. Okay. And once the original function is like this, it means if we restrict the y values, we also restrict the x values. So now, what do you think we should do in order to make this to be a function?
Also, you restrict the domain of the original function.
Yeah, but we don't have the original function here. So we only have the inverse. So when we restrict the domain of the original function, what are you restricting on the inverse?
The range.
Means we are restricting the range. But look at what is happening carefully. So we have an intersection point here. So meaning because we have a point there, they actually want us to have the bottom part of the function. You see that? Because of A. So if we want the bottom part of our function, what that means is we will need to restrict such that what we end up having is y. So if you look carefully, we'll go to the range of v of x. So what we are going to say to the range is y must be less than or equal to 0. Do you understand that?
Yes.
Okay, that is all what we had to do. Why did we choose the lower part? It is because we have a point that we are given here. Okay. Let me see. Let me think about this carefully. Let me put up the original graph. So for the original graph, if we are saying this, then it means the original graph would only be looking at this part here. Okay. Yeah, no, that is okay. Let's carry on. And then they say that determine all values for which our function w of x is less than 0. So let's have a look at what is happening there. That is 5.1.3. So that w of x, we already have it. So w of x equals log. And remember, for log, when there's nothing written, we will assume that we have a base 10, okay? And they are saying that this log must be less than 0. So this will be 0.1.
Why are we assuming that we have a base 10? I didn't know that.
It is because that is what your curriculum dictates, that you have a base 10 when you have a log that has nothing. Okay. So you should make notes of that, okay? Then now we need to solve for x. So how do we find the x? You just take the base up. So your x now becomes less than 10 with base 0. What does that mean? It gives you an answer where your x will be less than 1. So meaning for x values that are less than 1, our graph will be negative. And look carefully, here's 1. Our graph becomes negative for x values that are less than 1. So we are happy. Do you understand?
No sense.
Okay, which part do you not understand?
I'm still confused about the 10 part, but okay. The answers are you say, please re-explain what you just said.
Okay. So what I said to you was that if you are given a log, so let's say you have log like this, and there's nothing here, you have log of x. What is assumed in your curriculum, we use a standard base of 10. So if you don't see anything here, what you should do is to use base 10 for log. That is what you do. Okay. So in our problem, they were saying that we need to look for values where our w of x is less than 0, meaning negative. But we know that our w of x is equal to log of x. But because there was nothing, I put in a base 10 and then I say less than 0. How do you remove a log? How you remove a log, you take the base of the log, you make it to be the base on the other side. This should be 0. You take the log of the base, you make it the base of the other side, then you leave whatever which is here, meaning x less than 10. Then now 10 becomes the base. What was there becomes the exponent. 10 to the power of 0 is 1, so x becomes less than 1. But then we need to be mindful of the fact that our graph really can't touch that x is equal to 0 line. So we can even say, but greater than 0. So that becomes our answer. Do you understand?
Yes. Yes, sir.
So the reason why we are putting the 0 here is because that 0 there is actually the asymptote. That is where it comes from. So the graph can't cross that 0 line. Okay, so let's put it even the side. So, but it should be greater than that. Do you understand?
Yes.
Right. So let's go to 5.1.3.2. So 5.1.3.2. So what they're saying there, they want x values for which our w of x is less than negative 7 over 10. So we know w of x, that is log with base 10, and this should be less than negative 7 divided by 10. So what was the base of the log now becomes the base on the other side. What do I mean? It means we are going to have x is less than or equal to 10. 10 becomes the new base, then to the power of negative 7 over 10. But then we remember that this will always be greater than 0. Why the 0 should be there? That 0 there is an asymptote. So that becomes the x value which we have. You can try and simplify it if you want. What do we get? We get x is greater, is less than or equal to what? When you punch your calculator, 10 to the power of negative 7 over 10.
You 0,10, sir. 0,19.
0.19. Okay, then greater than 0. And this here becomes what your teacher will be happy of. Okay, let's go and have a look at the next question. Do you understand?
Yes.
Okay. So I hope you did get them right. If not, hard luck. It happens. Let's have a look at this one.
I'm writing the paper.
You are what?
Writing.
Okay. So let's have a look at this one. So 5.1.4, that is v of x is determined. Wait, if a v of x is as determined as in 5.1.2, write down the equations of the inverse. Okay, so now we need to think carefully of the decision we took there. So our v of x, so now what we need to do is to figure out the inverse. So remember, we have v of x equals, now we took the plus, the minus root. So our view of x were restricted such that we focused on this. Now they are saying, what is the inverse? So we need to go ahead. So y equals negative square root of x. So now we need to go and do our inverse here. What we do is we swap x and y. So we have x equals negative the square root of y. So what we can do is square both sides. So let's copy this and just put it here. And all what we are going to do is to just square the side and square that side. Okay. Then what we end up having is x squared equals y. That is what we have. So our inverse becomes x squared, like that. But we need to be careful of our.
No, I'm asking about, you see our HOD name. When he narrates our papers, he said when we write the inverse of a function, there must be a condition
Yes,
next to it.
that is where we are going to.
Oh, right.
So we have our inverse. Now we need to think the original function we restricted. So remember what the restriction we put. We chose the original function to have this restriction where we are saying x, where we are saying y, the range must be less than, y must be less than or great or less than or equal to 0. So it means when we come here, because they are saying make sure that it corresponds to what you said here, it means we need to say x must be less than or equal to 0. And your HOD will be so proud of you to say, this one understands what is happening here. Do you understand?
Yes.
Yeah, so your HOD will smile like this with big eyes. Good things happening in the office. Let's have a look at 5.1.5. So 5.1.5, they say if h of x is equal to this w of x minus that square root, calculate the range of h of 1. That is interesting. Okay. Let me see what these guys are saying. So they are saying if we take the W graph, is this one, and we subtract the other graph for that square root, where the range of that is from 0 to infinity, that is the x, calculate the range of h of 1. Okay, no, this should be easy, it shouldn't. So this here, they are just looking for the y value. So if you look at h of x, what they are saying is we have w of x minus the square root of x. Then when they say h of 1, all what they are saying is just plug x equals 1. So if we go to our problem, we know what w of h is. That is log. Let me move this down. So we know that this is log, and then we'll put in 1 minus square root of 1. So what h of 1 means is wherever you see x, plug in 1. So what do we get here? There's the answer. Log of 1 is 10. Sorry. Log of 1 is 0. So our answer becomes -1. That is it. Do you understand?
So for your metric, you got how many percent
For what?
maths?
All what you need to know is it's a distinction. It was good enough. So yeah. So yeah, it was good enough, to be honest. It was good enough to get me to vets, to get me to do engineering, to finish. Yeah, so my understanding of maths is matured. And yeah, it's beautiful, isn't it? Maths.
Yeah.
Look at these questions. They all make sense now when you look at them. You're like, okay, that makes sense. It is actually not hard. 11 marks, all in the back. What are you saying?
I'm saying the question was not hard, even though we were complaining. But
Yeah, tomorrow you should go to your classmates and say, no, this is, guys, we don't understand what we were doing. This thing is so easy, restricting, solving, restricting, solving. So your classmates shouldn't say, we were never taught this in class. That might
we
not.
were never taught, like, honestly, we were never taught, like, my maths teacher, Shem. Yeah. Wow.
Yeah, no, it happens. Let's pass that and go to our next question. So I'll crop this and we focus on the first part. Where is my crop function now? Let's move this up. And okay, Let's focus on this one first. Okay, let's zoom in and see. So this one reads here, the graph of f of x is 3 to the power of x is sketched alongside. Then they say, give the coordinates of A. So this is a very simple.
This is a parabola. Is this a parabola?
Oh, let's go to the parabola one. Yeah, there's the parabola. So my apologies, I was looking at the top question. So let's have a look at this nice parabola here. And let's see if it is hard. Not so visible on my search. Sketched is the inverse f, and the point A is the point that is here. So let me just rewrite it. Our A is 8 and minus, or 8 and 2. Okay. Then they say determine the equation of f, which is this graph here in the form of that. So let's go ahead and figure out what is happening. So if you remember, you should remember that I taught you 6.2.1, that if we have the original function, and we're looking at a parabola, the original function is y equals ax squared. I showed you that the inverse is actually the same as y equals plus or minus the square root of x divided by a. Okay, that is what I showed you. Do you remember that?
Yes.
So now it means we just need to figure out which of the two inverses first are we working with. Are we working with the plus or are we working with the minus looking at the graph? Which one are we working with?
The plus.
Yep, if you look at the graph, it is the top one. So meaning we are working with this equation here, x over a. Now the issue is we don't know what a is, but we know a point that is given. We are given 8 and 2. So we are going to use that point to solve for a. So y is 2, square root of our x is 8 divided by a. So what are we going to do? We are going to go and square both sides. Okay. So let's go ahead. We are going to do square this one and square that one. So we end up getting 4 equals a divided by, 4 equals 8 divided by a, and we know this is over 1. You have done cross multiplication before, cross multiply this way, so that what we end up having is the goals multiplying. That will be 4a equals 8. And if you solve for a by dividing by 4 and 4, you will see that the a value is 1 over 2. Now, if we go back to our equation, we can plug in our 1 over 2. So our y will be square root of x divided by 1 over 2. But we know that dividing by 1 over 2 is the same as multiplying something by 2, isn't it?
Yes.
So that becomes that. So the equation f of x will be the square root of 2x, like that. And this is our answer. Do you understand?
Yes, sir.
You're very smart, isn't it? Let's go to the next one. Then they say, hence, determine, and what you need to note here is that for this function, do you see that what we have is a y value that is greater than 0? This is our range. Okay, there's positive y values. Now the next question, 6.2.2, they want us to do, guess what? The inverse. And us, we become so happy because we already know what this means. When we have our range You can see that this is going to be our domain. So let's take what we have here. So we have f of x, which is square root of 2x. This we can write as y equals square root of 2x. Let's go ahead and do our inverse. And the first thing we do is swap x and y. So if we swap x and y, we end up getting x equals square root of 2 times y. And guess what? We are going to go and square both sides to solve for y. So let's copy this and put it up here. And then we square and we square. Then what we end up having is x squared equals 2 times y. And guess what? We can solve for y now. So therefore, our y equals, if you look carefully, divide by 2, it will be 1 over 2 x squared. So now I can go ahead and say my inverse will be equal to a half x squared. But because our range was restricted, we now need to restrict the domain. So our range, we said, it has positive y values. So it means we must say this one here is positive x values. This restriction here is very important. Do you understand?
Yes, sir.
So are these things hard? Or you are seeing the light now?
Hmm. I'm seeing the lights, sir. I'm seeing the lights.
Is the light bright enough?
If I practice more, it will be bright enough.
Yeah. Then let's go to the next one where we're looking at 6.2.3. So what are we saying there? They say give the coordinates of the turning point of the inverse at x plus 3. Then I think that is minus 1. Is that minus 1?
Yes, sir.
Okay. So let's go ahead and plug that. So we have x plus 3 minus 1. What does this mean? It means wherever we see x, go and put x plus 3. And this is squared. Then you minus 1. And guess what? We have done this several times. You should be smiling because you should be able to see that you actually did an equation which was of the form a into x minus p whole squared plus q. And your turning point is you would take the negative of that. So your turning point would be something like negative of p. So it would be negative, negative. So it would be p and q. So when we look at our problem above there, you will see that we will take negative of minus 3. So our turning point will be minus 3. And we take this one as it is, minus 1. And the teacher will say, this one is a genius. They should be in grade 14 now at university because why? Why should they get this right? Well, it's because they are smart. Do you understand what I did here?
Yes.
So is maths hard? That is my closing question. Are inverses hard?
No, inverses are not hard. Yeah, they are not hard.
Yeah, so none of this question needed you to have a big brain. They needed you to understand the fundamentals, which is what we were speaking to when we started here. What is the problem with functions when you are finding inverses? And how do we deal with that and making them functions? We restrict the range. But once you restrict the range, which I speak to, where is it? Somewhere here, where I say when you restrict the range, it is the same as restricting the domain of the original function. Once you understand this game here, you are done with inverses, especially parabolas. All of them should be easy. You feel a bit more confident now.
Yeah.
Right. So if
Yes,
you
I
feel
do.
confident,
I do.
it means we can pause here and you can go and do practice and solve mini problems and go to school tomorrow feeling like superstar and help everyone. So what you couldn't learn in a week, you have just learned
One.
now in 1 hour and you understand it. It's beautiful.
So let's challenge your mark. You see, let's challenge your final mark. What did you get for your finals? Grade 12.
No, that no, that should remain mine. But I think maybe let me send it to you. It shouldn't be. But why do you, or you want to challenge it so that you get something better?
Yes. Let's say I
Oh,
get something better.